Okay, now let's move on, guys. Okay, so we're talking about this date and date time can be used to represent dates. When you have a date of birth, you want to store that as a date, so you can use these two, date and time. Okay, decimals can be used when you want to store decimal values. Okay, double double precision unsigned, all this can be used to store your double values like decimal values. Okay, what are the difference? The differences would be on the range, the differences would be on the values that is allowed to be stored, and we will see that in a separate table someday. Okay, now blob, as I said, blob is used to store what? The objects, right? So binary large object, as I said, if you have an application where you want to store a file from let's say from the UI it is coming, or from anywhere it is coming, and you would like to store that file in your database, then you can use blob. And blob can be medium, tiny, large, or simply blob, right? Medium integer unsigned, they are like integer type which can be used to store all the integers, right? And sign and unsigned means whether you want to store negative values or not. If you say unsigned, it does not store negative values. Okay, it stores only positive values. Medium text, medium text is for, again, storing the text. We have already understood that. So we can store the text which is like a little larger than just the tiny. Okay, multi-line strings can be used to store multiple lines. You might not use this a lot. And multi-line string, multi-point, multi-polygon, they are used in geometry. Like I have worked with Apple Maps, and when you want to uh, store this maps data like a shape, right? So in that case you would be using this multi-line string, multi-point, and multi-polygon. uh, you would use this only when you want to work, when you are working with what shapes. And I don't know if you would ever work with shapes or not. Okay, so numeric can be used to store the numeric data. We'll see all the differences as we move on. As I said, this is the introduction. Okay, point, polygon again are for maps. Okay, so you can just ignore it blindly because I don't think you'll be ever be using those. So if I talk about India's boundary, if you want to store that India's boundary, then you would basically use polygon, multi-polygon, and all. Okay, points. If you want to store, let's say, the road, if you want to store the data of a road from this lane to that lane, then they are basically 2 points, right? So you would use that. You would use point to store that. Okay. Real, I have not used it. We'll have to check it out what exactly it does. I don't know, to be very honest. Set allows you to store the data with permissible values only. Okay, we'll see that. Small int unsigned, again they are all integers. Now it depends whether you want to store positive value, negative value, and you can choose unsigned or normal as usual. Okay, next, double unsigned. We know double can be used to store the decimal value. Enum, again a set of permissible value. Float, to store the floating values. Geometry collection, again for maps. Okay, now integer int unsigned, integer unsigned would do the same thing for you. Okay, it's just two different data types. Line string, again for maps, or I would say not map, I would say for shapes, because a map is also a shape, and some other shape can also be used, right? For example, I can also give you this as an example. Let's say you are using some software to design the structure of a building. Now those structure of a building are what? They are all shapes altogether, right? So you can use all this line string, geometry, and all to store such data. Okay. Again, variable binary, to store binary data, but long variable binary means it can store huge amount of binary variables, right? Long varchar, it is like a long version of varchar. Varchar is for small, whereas if you have more requirement, you want to store multiple data, then it is long varchar. Okay, long blob, again Blob can be used to store anything, any file. So somebody asked me, can I store audio and video, anything? A raw file can be stored in a blob. Now it does not matter whether it is audio or video. Okay, any file, any valid file can be stored in a blob. It could be audio, it could be video, it could be a software file or anything, right? For example, have you seen there are some website which allows you to download some free softwares, right? So if you are designing that to be stored in MySQL, of course that's not a good idea. But if you want to say I want to store those data in MySQL table, then you can use this blob. Now whether you will use long blob or a small blob, that's up to you completely, right? But you will use blob for that. Next, text, to store textual data, and as I said, text is very common. Okay, timestamp, we'll talk about this. It can be used to store the time. Date is specifically for date. Okay, we'll see what the difference between all these four: date, time, and timestamp. We'll see that. Okay, tiny block, tiny int unsigned. As you know, they are all tiny versions. Tiny text, you know, they are all tiny versions. Variable binary, you know, this is basically a variable length of binary characters. Variable char, you know that char is fixed usually, and if you are not sure how many character it would go around, then you will use varchar. Year can be used to store only the year part. We'll talk about that. And there is a separate data type called JSON that can also be used to store your JSON data. Okay, so we'll explore this slowly one by one as we move on with different components. I just wanted to give you a overall highlight of this. Okay, worker 2 is not there here. Did you see that worker 2 here? No, right? So these are the list of supported data types. If you are talking about worker 2, then you might be talking about Oracle database data type, and the data type varies from database to database. Okay, now do you agree with me that if we actually group them together, then there are hardly very few types? Yes or no? For example, can I group them it like this? Let's say date and time. For date and time, if I go from here, if I start scrolling from here, I can see date, date time, date, date time, and I can see time, timestamp, right? And I can see here. Can I say that my date and time type are basically this, right? And again, if I say I want to put all, let's say, integer type, right? So what I'm trying to tell you is you can actually categorize this. You can actually categorize this. Now, if I talk about integer type, now you see you have int here, right? So let's take one example. I'll not do it for everything right now, but I can do it offline. So I'll just do it for one. Okay, I'll talk about integer type. Now see here, you have integer, right? Now when you have integer, when you have int, you also have int unsigned. Okay, so I'll put it here also, int unsigned, right? And then you also have big integer for that. You also have big integer for that, and you have big integer unsigned, right? So now let's go a little down. Let's go to t. Now you have tiny integer here, and you have tiny integer unsigned. right? And so on, right? So if you see, these are all same. Like you want to store integer kind of data, then you can use integer or integer unsigned, or big integer or big integer unsigned, tiny integer or tiny integer unsigned. Now, if you want to put them in a more organized way, you can say, let me first say tiny. Let me first give let me first give priority to tiny, then integer, and then big integer, right? Likewise, if you look into text, then there is also something very similar. Okay, likewise you can classify it all together. Okay, so if you see, there are very few types, guys. Okay, so you don't really have to worry a lot about this. There are only few types. Date and time, there are few. And as I said, integer type, there are few, right? Character type, there are few. Geometrical type, I will say all this point, polygon, and geometry collection as a geometry type, right? Line string as a geometry type, and so on. Okay, now there's a question about the difference between daytime and timestamp. We will see that with the practical example. The only difference would be the way they represent the data. Okay, now let's move to the next, guys. Now let's talk about operators. Okay, now operators are very useful and we would be using it every day in our SQL queries. There are types of operators. They are like arithmetic operators, relational operators, logical operators, and select operators. Okay, we'll explore all this step by step. Now, arithmetic operators are like plus, minus, into, divide. Relational operators are like equal to, less than equal to, greater than equal to, and not equal to. You can write not equal to like this, you can write not equal to like this. There are two ways to write a not equal to. Okay, again, logical operators are like and or not. Okay, select operators are like this: in, between, is null, like, or not in, not between, is not null, not like. Okay, you will come across all these things as we move on. We do a lot of uh, examples and we will practice all these things one by one. Okay, now before you even start exploring this, I want you to create a table before we start exploring the operators. Okay, so what we will do is, there is a very popular table in Oracle database, employee and department, right? So let us take that data and start practicing all these operators. Okay, so the first thing that I want you to do is just go to Google and say employee department table script Oracle, because this table concept, this employee and department are basically given by Oracle long back, and all other databases have also started. Like whoever is teaching you SQL, everybody talks about employee and department, but it has actually come from Oracle database way back. Okay, now look into this. You can get this script from a website called Oracle Live SQL. Click on it. Okay, and here is the script here. Okay, see, I'm not just showing you to copy, I'm just also showing you from where you can actually get this. Now if you see, this article itself was created in 2015, almost 9 years ago, right? So you can create your department table, you can create an employee table. Okay, now look into these tables. You can see create department. Let me zoom it a bit. Create department, sorry, create table department, right? Department number, department name, location, and I'm saying this department number I would like to put as a constant pk underscore department. That's the constant name. And what kind of constant you are giving? Primary key to what? Department number. Okay, we'll talk about the primary key separately, but right now our main objective or intention is to learn the operators. Okay, so really don't worry about what is a primary key. I have given you a little highlight, that a primary key is a key which is always unique, and there would be only one value in the in the table, right? Then you would get a little confused. What is a unique constant? Then we'll talk about that separately. But for now, just say that primary key are unique keys. Okay. So I'm saying I want to create a department table with three columns, and I would like to put a constant of department number. Done. So let's do this. Okay. Now when you copy this script, it is not important that it would work, because the data type may differ, right? See here, you can see varchar2 is written. Varchar2 is not a data type of SQL. You'll have to convert this into MySQL. Okay. So one way could be, let's say, employee department table script for MySQL. Just Google it out and see if somebody has given you a MySQL style database or not. And if you see, you can have, if you see, you have this here: create table department number, name, location, and it is no more a varchar 2. It is no more a varchar 2, right? And that means they are probably compliant to MySQL. So you choose it accordingly. Okay, if you just Google it out, you'll get to that. You'll find this very easily. It says, judging by the data, this has been around since 1982. Most of us, including me, was not even born at the time this script was created, right? That's the power of this script. So if you see, it is Scott. Scott was probably one of the employee of Oracle. Again, he has created all this script, and this is like a SQL, MySQL compliant script. So just Google it out, and then you'll find it out very easily. Okay. What I've done is I've already done it here. See here, create table department. Okay. Now what I'll do is I'll go back to this and let me first drop this table, because I know the table is created. So I'll say delete. Okay. It says there is a foreign key concept. So let me first delete the employee table. And then let me delete department table, and then let me say refresh. Now my employee and department is gone. Okay. Now let me do what? To make things easy, let me also delete all the tables, because I don't want any confusion, and we are going to work with employee and department. So let's say delete. Let's say delete all this one by one. Done. Okay. So I've deleted everything. Now let's start fresh. The first thing, create table department number, department name, location. And we are saying, while I create this department table, I want to define my department number as a primary key. And let's run this. This will create the department table. So just refresh, and you see there's a department table. Now likewise, check this out. We're saying create table employee. Create table employee. Employee table would be created. Employee number, employee name, job, manager, hire date, salary, commission, department number. You don't have to worry about these column names. They are just the column names, right? And what you can see is here we have employee number as a primary key. We have employee number as a primary key. And we have also used this department number as a foreign key. And as I have told you, I'll talk about the concept of primary and foreign key little later. Don't worry too much about it right now. Okay. So let's create this also. Done. Okay. So I've created department table. I've also created employee table. Say refresh. Done. Now I would like to ask you a question. Let's see how many of you can answer this correctly. Okay. Why did I create department table first and then employee table? Why did not I create employee table and then department table? Absolutely correct. Because while creating employee table, I'm saying I need a foreign key. And this foreign key would come from the department table, right? And hence, I had to create department table first and then employee table. Okay? Which means one particular column is used here as a foreign uh, as a foreign key. Okay? So, department was created first and then employee was created. Done. Now let us start inserting data into those tables. Okay. Now the first command is this. Let me go here. See here. The first command is this. Insert into department, department number, department name, location, values. This is one technique which we have already studied, right? Insert into by specifying what? The column name. So let's run. This will insert one record. Done. Next, we've also studied that if you want to insert all the values, then you don't have to specify this column names here. Directly say insert into department table and give your value. This is approach 2. Done. Okay. Now, likewise, if you see this approach 3, wherein I said I want to insert a value like this, and I don't want to write multiple insert. Let me just say values, and then let me give first set, comma, second set, and all these things we have discussed in our last class, right? So let's do let's insert 2 more record using the approach 3. Done. Once it is done, 1, 2, 3, 4. 4 records we have inserted successfully into our department table. So let's go to this department table and say refresh. And go to your data here. Okay, so we have got the department number, department name, and location. What are the types here? Type is text. Okay, type is text. See here. You can see here type is text. Okay, and text are represented like A to Z. When you see something like this A to Z, understand it is of text type. Okay, department number. If you see there is a key here. Do you see one small key here, orange color key? That means it's a primary key. Okay, and 1, 2, 3 means it's a number, integer. Okay, so that's how you should actually understand it. Okay, done. Now let me go back, and now let us try to insert into employee. Okay, so let us try to insert the record into employee table. So we have already done it here. Let's go to the script, insert into employee. Now values. Now look into this. I have used a function here, string to date, which we will talk about later. But what I wanted to do was, check it out, employee table, see the script of employee table. In the employee table, employee number is integer, employee name is text, job is text, manager ID is integer, hire date should be a date, right? A proper date. So is of date type. Salary is of float type because everybody would get a salary like, let's say, let's say 50,000 rupees 50 paise probably, okay, whatever it is. Commission integer, department number again integer. And now there are some constants, right? So we will talk about this primary key and foreign key concept separately later. But what is important for you here to understand is this hire date is of date type, and I wanted to insert that to date. So there is a function called string to date. We will talk about this date function in a separate topic. Right now my job is just to show you how to fulfill the requirement and create the employee and department table. Okay, so let's try this. So we have inserted one record. Let's do this. Second record. Let's do this. Third record. Let's do this. Fourth record. Let's do this. Fifth record. Okay, you can do this one by one, or you can write a single query, insert into the way we have done, and push everything in a single query as well. Choice is yours. Then do it for everyone so that we have our data intact. Done. So we have inserted a lot of records. Okay. Now let's go back to the table. We'll refresh our table. Say refresh. We've got our employee table as well. Let's go to employee table. Now look into this table. In this table, it's very clear that employee number is a primary key of integer type, and these are the employee ID. Okay. Name A to Z means text. Job text manager 123 integer. Hire date, if you see clock symbol, okay, that means it is of date and time format, something very similar. Salary is 123, that means it is a numeric, but if you go a little more, then it is actually a float. Commission is again integer. Department number, now if you see this department number, you can see there is a small foreign key icon here, right, something is flying out. So that basically means a foreign key. uh, so if you see this example, we have successfully loaded employee table, we have successfully loaded our department table as well, right? Now let us go to, there is one more option here, ER diagram. Check it out what exactly it is. Let's see this. See this. The beauty of the deep viewer is it gives you a ER diagram as well. If you have everything intact, it can show you the ER diagram. It can tell you how the tables are related, right? You can actually if you have more than 2 tables, 3 tables, 5 tables and all, you see the ER diagram here itself, and that helps you to understand how these tables are so related, how these tables are correlated. Might not make a lot of sense when you deal with employee and department, but in the real world you will find a lot of, you know, tables, and all these tables are related to one or other way, and you should see a complex ER diagram. Okay, now let's move to the next. So we've inserted all our records, right? Okay, now let us start our first operation, that is arithmetic operators. Okay, so arithmetic operators are used in numeric data type column. Arithmetic means what? Doing some arithmetic operations, right? And they are supported only on numeric data type, of course. Okay, arithmetic operator is used with select statement, something like this. Something like this. Select, name, salary into 12, something like this. Relational logical special operators are used with where condition. We'll see that as we encounter them. Arithmetic operators can also be used with where condition. We will also see that. Okay, now let's practically experiment them. Now I'll go with the questions. Okay, we'll pick up the question on those database and we'll start exploring all the stuff. So the question is display name, salary and annual salary of the employee. So how do you write that query, right? It's important that you understand how you should start writing the queries now. Okay, so this is done. Now you want to write some queries, right? So first thing that you do whenever you are writing your SQL query is, the first thing that I would suggest you to do is select star from table name. So select star from, what is the table name? Employee. Okay, select star from employee. This is the first thing that I want you to do, because when you do that you get a sense of what are the things that are available, right? Okay, done. I saw that I have all this stuff. Now what is the assignment? Display name, salary and annual salary. Name, what is the column name? I want you guys to help me out here. What is the column name that has stored the name of the employee? So select ename. Okay, and what is the next thing that I'm asking for? Salary. What is the column name of the salary? Check it out. Cell. Okay, cell. Okay, all right. Now what is the next thing I'm asking for? Annual salary. How do you get the annual salary of an employee, assuming there is no deduction? Into 12, right? So salary into 12, right? Now from which table? From table name. What is the table name? EMP. That's it, right? So this is a query to get name, salary, and salary of the employee from the employee table. So let's run this query. Now when I run this query, if you see, I got the name, I got the salary, and I got salary into 12, right? I got salary into 12, which is this. Now you may not be happy with this column name, right? If you see, the column name is salary into 12. You're not happy probably with this. You may say, I want to rename this. So what can you do? You can do something like this. You can say, this particular column, whatever operation I'm doing, okay, as annual salary, which means you are giving a new name to this column as annual salary, right? When you do that, then what will happen is like the column name would not be cell into 12. The column name would be annual salary. Okay, this is what you can do. Now again, this as is also optional, guys. This as is optional. Can I write something like this? Let's see. Yes, it still works. That means this is optional. You can write as, you can omit as, no problem at all. Okay, they are optional, which means you can use as or you can ignore it completely. Okay, so we have completed our first task. Done. Okay, you mean to say there should not be a space in the new name. See, ideally, that's a bad practice of SQL itself. Think about this, right? That's a bad practice of SQL. The SQL standard says whenever you are creating a table, right? When you say create table EMP, and when you define your first column employee name, this is wrong, right? Which means this itself is wrong. Okay, so you should not give any space around here because that would lead to uh, that would lead to the error for sure, because I don't think this would work. But let's try this out. Okay, but let me try something like this. What if I say like this? What if I say, can I do something like this? Done. But conceptually this is wrong. You should not do that. Okay, always if there is a space you should say underscore. Clear? I'll put it here also. And I would say wrong practice. Use underscore to separate the words. Okay, perfectly wrong practice. Never ever do that. Done. Let's move to the next. List all employees earning more than 30,000 annually. See the question. The question is list all the employee who earns more than 30,000 annually. Okay. So that's the thing that you need to find out now. List all employee earning more than 30,000. How do you do that? Simple, right? So again, the first thing that you do is say select star from employee. Whenever you are writing any complex query, the first thing is say this. That will make your life easy. On top of it, now you start working. Okay, so I need all the employee who is earning more than 30,000, right? So let me see what are the fields we are retrieving. So we have retrieved list all employees. I would just add this employees name, salary, annual salary, who is earning more than 30,000 annually. Okay, so it's clear that you need a name. So you say select. Now what the column you need? Name. Okay. What the next column you need? Salary. What the next column you need? Annual salary from employee. Okay. Now let me run this query first. All right. Now I'll say as annual salary. Let me write this first. Done. Okay. Now what the condition? The condition is I want to fetch only those who are making more than 30,000. Who are making more than 30,000, which means this guy should not come, this guy should not come. Right? Which means definitely there is a where clause. Where? Where? I want to ask you a question now. Can I write annual salary? Can I do something like this? Yes or no? So let's try to run this code. Okay, I'll say run. Now it did not work. It says unknown column annual salary in where clause. Now the point is, if you are using alias here, you cannot use this alias here. Okay, so you are forced to write. You're forced to write annual salary. Sorry, I did the same mistake again. You're forced to write salary into 12. This is what you are supposed to do. Okay, and we can see we got the list of all the people making more than 30,000. Okay, now check it out. You cannot use column alias in the where clause. The below code will fail. This code will fail. Okay, however, let me show you one more thing. Can I do something like this? This is a little advanced. This is a little advanced, but I'll teach you in the coming days. Okay, so this works. Okay, this will work. We call it inner query. Okay, or we call it nested query. You can, however, use it in inner query. Okay, as I said, I'll teach you this concept later. Don't worry about it right away. Okay, but what I've done here is, see, I was not happy with that. I was not happy with that, salary into 12. Okay, and hence I said, let me do it this way. So what I have done, see here, this actually means this table. See here, let me run this. This means this whole piece of table. Right? Whatever I've written here, this will give me the whole piece of table. It has given me the whole piece of table, right? The whole data. And this whole data, I have executed another query. This inner query and this outer query. And I'm saying, select start from this particular table. Let me call this table as E. Now, since this table is already created, this table has got a field called annual salary, and I'm allowed to refer it saying E dot annual salary. Clear? Little clear? Okay, so let's move on. Let's talk about relational operators. Okay, now you can use this relational operator in where clause only. So, for example, what are the example of relational operators here? We talked about arithmetic operation, and I have shown you, plus. But you can use minus into divide as well, right? For example, give a salary hike of 20% to everyone, then you will use into. Is not it? So that also comes under your arithmetic operation, right? So let me frame one more question here. I would say I would say list all the employees. I would say give a hike of 20% to all the employees. Okay, and let me say, do not update the data. Do not update the data. Just fetch the data with hike. So what I'm saying is, I'm not asking you to run a update query. I'm just saying, fetch the data, do a select, and see what would be the output when I give hike of 20% to all the employees. So I want you to help me out writing this query. Everybody, please. Let's see how many of you can help me out. I want to give a hike of 20% to everyone. So I'll first say select start from employee. That's the first thing I would do. Now everybody should get 20% hike, right? So I'll say select. I would get name. I would get salary, and I would get salary into 1.2 as new salary from employee. Will this query work? Yes or no? If you just say yes or no, I will understand that you understood. Will this query give me the desired output? I wanted to see what would be the value of the salary of all the employees after getting 20% hike. Let's run this. So what I saw is somebody who was getting 800 would now get 960, right? So see here, somebody who was getting 3000 will now get 3600, right? So looks like it is a 20% hike, which means this query is perfect. Okay, so which means based on the requirement, you can use your arithmetic operations the way you want, right? And if you remember, we had mentioned a point, arithmetic operators can also be used with a where condition, which means here, right? In the where condition, we have also used arithmetic operation. You can use it here as well. Okay, that's the meaning of that line. Okay, now let's talk about this relational operator. So we can use this operator in where clause only. Okay, so let's see what are the examples of relational operator. Relational operators are this. These are your relational operators. Equal to, less than equal to, greater than equal to, not equal to, and as I said, not equal to can be written in these two format. Okay, let's explore with some example. Okay, now the question is like, list all the employee who are not clerk. Okay, so your query would become this. So let's do this. Okay, so the first thing that I want you to run is select star from employee. Done. Now what the question? The question is, give me the list of all the employees who are not clerk, who are something else. So see here, there are few people who are clerk, and the question is, I don't want clerk. I want anybody, everybody else, but not clerk, right? So you would say your query would be select star from employee where job. You need to check the job, right? So job, you can say, is not equal to C-L-E-R-K, clerk. This is one way. See here, you got everybody but not clerk. Okay, and if you want to get only clerk, you got only clerk, right? So I'll also put it here. Okay, let me say, and I'll frame the question here. List all employees who are clerk. This is the query, which will give you all the clerk. Okay, now the question is, give me all the employee who are not clerk. So you will either write it like this, not equal to clerk. So let's see. You got everybody who are not clerk, and instead of this, you can also use this symbol. This also gives you the same thing, same output. Okay, so we have seen this symbol, right? We have seen this symbol, we have seen this symbol. These three symbols we have already seen, right? So here it is, equal to, not equal to this, right? Now we are left with these symbols. Now these are like less than equal to, greater than, greater equal to. So which means you can have a query like this: list all employees earning more than 2000 salary. So if that's the case, then your query would be select star from employee where salary is what is the question? More than 2000, is more than 2000. So these are the list of all the people whose salary is more than 2000. Right? Now, instead of this, you may say, I want to get the list of all the people who are getting less than 2000 or less than equal to 2000. That includes 2000 as well. So your query would become like this. These are the list of people who are getting less than or equal to 2000. So I would frame one more query here. List all employees earning less than or equal to 2000. Okay, now your query would become like this. Alright, so this is how you can actually write your relational query. So we've also explored all the relational operators, right? So I've shown you for this, the rest two are also same. So good morning everyone, let's continue our discussion. So we'll start with data types in MySQL. Okay, now in previous examples we had created a small table like employee, right, with some columns like employee ID, employee name, employee salary, right? And it is very important for us to understand what kind of data should I assign it to, right? What type of data type should I assign it to? For example, if I talk about ID, right? So you need to think about like whatever ID I'm creating, whether that should be an integer or that should be a character, that should be a float, or that should be something else. So MySQL supports a varieties of data types. Okay, and I've just listed it down. If you see, they are almost I think 40 plus. So let's check it out. If I just start counting it, 1 2 3 4 5 6 7 8 9 10 11 12 13. So on an average 13 26 39 50, almost close to 50 data types. Okay, so these are the list of all the data types that are supported in MySQL, and these data types may differ from database to database, which means if you are copying a code or a script from another Oracle database or some other database, then there could be some different data types. For example, if you talk about Oracle, then in Oracle there is a data type called number. Okay, whereas if you talk about MySQL, then we have something called int. Where is that? Go to int here. Okay, so it differs, right? So you can have different data types altogether. So if you're working in multiple databases, you'll have to check the document to understand what are the data types that are supported, and you'll have to adjust the script accordingly. Okay, because sometimes what happens is like you want to create a table, you got a script, but that script is written in Oracle, and there are some data types which are supported in Oracle and which is not available in MySQL. So in that case, you need to first understand what could be the equivalent data type. Okay. Now I'll tell you the formula. How did I get these data types? Okay. So one way would be Google it out, go to the official documentation, and you should see the list of all the data types that are supported in MySQL. But I did something else. What you can do is, go to your viewer, go to your database, and just go to your any table. So let's say go to OLC training and go to table, right? And let me go to employee which we had created earlier. Okay, now see here, when you go here, then you have a lot of stuff here. You just go to the column. Now if you see, I have got ID of integer type, right? Name and salary. Now this data type is what? Integer, right? Now if you say, if I want to say, hey, I want to change this data type, probably click on it and then you get a list. See here, which probably means these are the list of all the possible data type, right? Is not it? Yes, no. Okay, so this is how you can easily understand what are the data types available. You can go to the documentation as well. The documentation should also give you the same stuff. Okay, but the easiest way to figure out all the possible data types are using this technique. Just say I want to change it, and then you'll see the list. So what I did is I took the screenshot of all this and I just pasted it here, nothing more. Okay, so these are the list of all the data types that are supported. Let us talk about the common data type, and we will explore a lot of data types as we move on. Okay, now I'll go to this table. Okay, let's go to this table and let's see the common data type that you would use every day. Okay, so let's start with this character. So this character of size is used when you are 200% sure that I need a data of this much length. For example, if you want to, let's say, store the Aadhaar number of a user, what is the total number of character you need? What is the length of Aadhaar number? 12. Okay, which means you are sure that if you're storing the Aadhaar number of a person, it would be 12. It would not be 11, it would not be 13, right? Neither it would increase in future. No, right? It is fixed. So if you want to work with such data type where the you would like to store the data and they should be a fixed string, right? And why would I use that string? So tell me one thing, should I use character to store Aadhaar or should I use integer, int? Should I use character or should I use integer? Character, right? So you should use char to store the Aadhaar ID. Why? Why should you use char on Aadhaar? Because it's not about space. A space is given to you just to make it readable. Okay, if you see your Aadhaar card, then you see there are spaces. For example, if you see this example, my contact number of OLC +91799, and then I gave a space, and then I gave a space, I gave a space. This is only for readability, right? But to be very honest, the reason why you should use char to store such data is because you are not going to do any arithmetic operation on it, right? Are you going to say I want to add to Aadhaar number? No, right? Which means you are not going to do any computation on it, right? You might just use it to extract. Like at max, you will write a query like this: select star from customer where Aadhaar ID is equal to this, exactly this, right? So hence you would use char to store your Aadhaar number, right? So fixed length string can contain letter, numbers, special characters. Total, this size is basically the total number of characters allowed. Okay, you can say how much character you need, and it can be from 0 to 255. At max you can store 255 characters. The default value is 1. Okay, which means if you don't store the data, okay, then by default it would be always 1. Now likewise varchar. Okay, now if you talk about varchar, then there also you can give a size. Okay, now if you don't give the size, then the default value is 1. Like in the char also, you can simply say I want to declare a a column, let's say Aadhaar, of character type, and if you don't give the size, then it would be default to 1. Okay, now varchar, if we talk about varchar, it is a variable length string. Now what is the meaning of varchar? See, var means variable. Okay, char, so it means varchar means character, but it can vary. Okay, it can vary, it would not exceed, but it can vary. For example, if I say I want to store the Aadhaar of a person, okay, but Aadhaar, I know that Aadhaar is of 12 digit always. Okay, but let us say for some government organization or for some particular reason there are 10 character Aadhaar as well, either 10 or 12. In that case, you would choose Aadhaar to be what? Varchar. You will say it would be a varchar of 12, which means I can store the 12 digit character Aadhaar or 10 digit character Aadhaar or 8 digit character Aadhaar as well. Right? Here you can give the size, and as the name says, it is a variable length string, which means you can have a small character Aadhaar as well. Okay, so can contain a letter, numbers, special characters. What is the size? The size is maximum number of character allowed. That is, it can go from 0 to 65535, and the default is 1. When you say default is 1, that means if you don't give the value here, then by default it is varchar of 1. Okay. Now you may ask me a question: if I have a character of 12, okay, and if I don't, can I give a Aadhaar which is only 4 digit? Yes, you can. But the point is, it allocates the whole memory, right? When you say character, it is fixed. No matter how much you are using or whether you are using it or not, it will always occupy that 12 characters in the memory. Okay, whereas when you talk about varchar, that means the size is not fixed. The variable, right? This size is the maximum size that you are specifying. Okay, and it can go up and down anywhere, right? So varchar can be used when you say my Aadhaar can be maximum of 12 digit, but in some scenarios I also have an Aadhaar of 10 digit for some XYZ reason. So in that case, you'll go ahead with variable character. Okay, now as I said, if you say character or varchar, right? So even if you have defined, let's say 10, you can still store 4 characters. That's not a problem. But the only problem is a lot of memory would go wasted if you just do that. So it's not recommended. Okay, so if you are sure that it is a variable type, better define varchar. Okay, if you are sure that a character Aadhaar would be only 12 digit Aadhaar, then you can just go ahead with your character, right? If it is variable, you can go ahead with varchar of 12, and let us store 12 size also there, and let us store a 10 size also there, because when you define a table and if somebody else sees your table, they should understand why it was defined as varchar. You should have a proper reason for that. Okay, next, binary. Now it is used to store the data just like your character, but it can store a binary byte strings. What do you mean by that? See, when you store for example, let's say when you are reading a data from a file, or let's say when you are reading the file, okay, when you do a programming and when you start reading the file altogether, okay, I'm not saying reading a text file, reading some file which are not text files, okay, they are all basically a sequence of binary characters, and if you wish to store such kind of information, then you can use binary. Okay, and it stores all the binary byte strings. Okay, and you might not be using it so much because most of the time you deal with what textual data. Okay, likewise you have variable binary. So binary means here size means fixed. For example, if you say, hey, I want to store some binary data, but I know that the total number of characters are fixed, then you can define the size here. Okay, now if you feel, hey, I want to store binary data, but my total number of size is not fixed, then you can say var binary. Okay, and it is similar to varchar but stores binary byte string. The size defines the maximum column length in bytes, right? So binary and then again variable binary. Likewise, there is something called blob. There is something called blob. Okay, so blob stands for binary large object. Binary large object. OB means object, B means binary large object. Okay, this can be used when you want to store the file itself. For example, you might have seen certain website wherein it asks you to upload your resume, right? See, think about this, naukri.com. You upload when you fill up your profile, it asks you to upload what? The document, right? Your resume. The resume can be MS Word. The resume can be in a PDF format. So how do you think that file might have been stored in a database? So if you want to store that directly in the database, of course, there are some other approaches as well. Okay. But if you want to store the file itself in a table, then you should basically use the concept of blob. Now, again, if you talk about blob, then if you see blob are of different type. One is tiny, medium, long, and blob. Okay. The only difference is in their size. So I've also specified what the total length. So if you see, maximum length is 255 characters, which means if you are storing a small file, and if that small file, when converted to a binary format, if that does not exceed 255 characters, then you can use tiny blob. Okay, medium blob can hold up to here. Your blob can hold up to here, and your long blob can hold up to this. So depending on your size of the file that you are trying to upload, you can actually use tiny or medium or long or simply blob. Okay. Now, if you want to store some lengthy characters, let's say you don't want to rely on varchar. Let's say you don't want to rely on char. But if you want to store some text, for example, think about this. You have created a block section wherein you allow user to write some content in a blog. Or let us say let us take it this way. Let's say you are writing a post in a LinkedIn, right? So when you write a post in a LinkedIn, you start writing something, right? And you want to store that data. You want to store that data in a database. So in that case, you can actually go ahead with your text. This char and varchar is for small characters. Okay. Whereas if you want to store big amount of textual data, I would say go ahead with text. Again, text can be of different type like tiny, medium, long, and text. So they all have their range. Here you can store maximum of 255 character. Medium text up to this much character, text up to this much character, long text up to this much character. So based on your requirement, you can go ahead with tiny version, medium version, long version, or simply the text. Okay. Now, likewise, you have something called enum. We will see all these things practically as we move on. It's just the introduction today, right? Enum. So enum can be used when you are sure that you have a list of values and you would like the user to enter only this specific values. For example, if I say I have a department name, right, in a database, and I want user to enter either IT or HR, or there are the list of few countable department name, right? Now you can define a enum, and you can say this field can store this data, this data, this data, and some other data only. So when you do that, it actually puts a constant, like, right? For example, somebody by mistakenly will not insert something else. Okay, so a string object that can have one value chosen from a list of possible values, you can list up to 65535 values in a enum list, which means if you define a column of enum type, then it can have 65535 values altogether, not more than that. Okay, now if a value is inserted that is not in the list, a blank value will be inserted. The values are stored in the order you enter them. So if you are trying to insert a value that is not in the list, then what will happen? A blank value will be inserted, but that value would not be inserted. Okay, likewise there is something called set. So what is a set? Set is very similar to enums here, a string object that can have 0 or more values chosen from a list of possible value. You can list up to 64 values in a set list. So in case of your enum, it allows you to store multiple values. In case of your set, whatever value you have defined, it allows you to store only one value. Here, a string object that can have 0 or more values chosen from the list of possible value, you can list up to 64 values in the set list. Okay, so set is like the list of all the possible values that is allowed. Okay, I know there could be little confusion, but I'll make it super clear as we start practically experimenting this. Okay, in our advanced classes, we'll start and we'll learn a lot about all these data types. We'll have a separate chapter on the data types where I'll teach you what are the use cases of it, where exactly, how do you define this, what are the permitted value, and what will happen if you insert this. Okay, I'll show you that practically all together. Okay, so at a very high level, these are some of the very common used data types. Date types we will discuss separately altogether. Okay, so let's go back to our data type list again. Now let us see this. Big integer unsigned are similar, right? They are used to store what? Integer data. And signed and unsigned means what? In a normal big integer, it allows you to store negative value as well as positive value, right? And unsigned means it stores only positive value. That's how it is. Binary, you can store the binary values. Bit, as the name says, you can store only 0 and 1. So if you have a requirement where you either want to store only 0 or 1, you can use bit for that. Blob, as I said, binary large object. Okay, now it can be used when you want to upload the files, right? Or you want to store the files. In that case, you can use a blob. And when you talk about blob, again there is a blob like medium blob and large blob and all, right? And then bool is for boolean. Char is for character. Date, we will explore a lot on this, date and date time. Okay, this can be used to